Hello students. So in the last video we completed the discussion about what is a chemical reaction and how to represent a chemical reaction, what are reactants, what are products, everything, all the introduction part. Now in this video, the continuation of this chapter, chemical reactions and equations, students, we have types of chemical reactions. Mainly we have to focus on combination reactions, decomposition reactions, displacement reactions, double displacement reactions, precipitation reactions and redox reactions. According to the syllabus, we have these many types of chemical reactions. If we go to the higher classes, we have other types also, students, like reversible reactions, irreversible reactions, combustion reactions, all the other types also included. Right now we have all these 6 types of reactions we will cover in this video. So let's start the discussion with the first type, combination reactions. First of all, students, why do we need to classify all these reactions? Classification anywhere helps us to study in a easy format, yes or no? So that's why we need to classify all these reactions. So first type of reactions are called as combination reactions. The meaning is, students, simple. What is the meaning of combination? Combined, yes or no? So in the chemical reaction also, an element or a compound or both are elements or both are compounds, they combine and they produce one single product. That is called as combination. A plus B gives rise to C. Understood? These type of reactions are called as combination reactions. The chemical reactions in which 2 or more elements or compounds combine together to form a single compound are called as combination reactions. We have the reactions given here. Hydrogen and nitrogen reacts to form ammonia. Yes or no? Hydrogen gas H2, nitrogen gas N2, both are combining and look at what do they form? Ammonia. Yes or no? How many compounds are there? Only one compound, SR NH3. Here some students will confuse, like, sir, here their number 2 is there, na? 2 compound. No. 2 molecules of same compound, SR no, different compounds, both same, SR no, 2 are ammonia, SR no. One is ammonia and one the other is not another compound, right? That is what the clarity is. 2 elements or compounds, when they combine, they produce a single compound. Single means the type is single. Okay, that single compound can be 10 molecules or 100 molecules or whatever. Got the clarity? Look at the next reaction. Carbon plus oxygen gas produces carbon dioxide. Here we have a carbon element and we have a molecule of element here. C plus O2 gives rise to only one compound, which is CO2. That's it. Understood? These type of reactions are called as chemical combination reactions. So next type we have a decomposition reaction. Simply opposite to combination is decomposition reaction, students. What is opposite to combination? What is combination? 2 elements or compounds combine to produce a single product. Yes or no? Or what is opposite? One single compound decompose or separate or break down to form 2 or more components. That's it. Understood? Look at the chemical reactions in which a single reactant breaks down to give simpler products is called as decomposition reaction, students. And we have the given example. Iron sulfate is a single compound, plus heat means we are providing heat energy. That's it. Don't think it's a compound. Yes or no? So iron sulfate is decomposing to produce iron oxide, sulfur dioxide and sulfur trioxide. In this reaction, on the reactant side, how many components are there? Only one. On the product side, more than 2. Yes or no? 2 or 3, it depends upon the type of chemical reaction. So this type of reactions are called as decomposition reactions. I'll give one more reaction. For example, CaCO3. What is the name? Calcium carbonate decomposes to produce calcium oxide plus carbon dioxide. Answer, this reaction comes under which type, students? This reaction also comes under decomposition. Yes or no? CaCO3 is a single compound. It decomposes to form 2 components. One is calcium oxide, other one is carbon dioxide, CaO plus CO2. These type of reactions where a single compound breaks down to form 2 or more other simpler compounds. These type of reactions are called as decomposition reactions. Very simple. A plus B gives rise to C. Combination. C gives rise to A plus B. Decomposition. Sir, can we write all the combination reactions opposite? No. Don't write that way. It depends upon the type of reaction. Not all the combinations, not all the combination reactions can be decomposed. So you have to check the reaction according to the given syllabus. By the nature of the compounds, these are all experimentally determined reactions. You have to follow that. You cannot write as your wish. So this is combination given here. I will write opposite in the decomposition, same react. No, don't do that. Okay. Some are possible, some are okay. For example, ammonia synthesis, that is reversible. Calcium carbonate, this is also reversible. Some reactions may not be reversible. Only one direction only they follow. How can you write opposite side also? Understood? This clarity also you have to maintain, students. Next, third type of chemical reactions are called as displacement reaction. Simple. A chemical reaction which more reactive element displaces the less reactive element from its salt solution is called as displacement reactions. For example, you are in a class. Okay, you are in a class. You got the first rank in the class. Okay, you got what rank? First rank. Because of shuffling, one student joined in your class. Okay, and this student is topper than you. Then what will happen in the coming examination? This topper student, definitely he will replace you. Yes or no? Why? He is a merit student than you. Understood? Got the clarity? Similarly, in a salt solution is made up of a metal and other non-metallic part. Yes or no? If any highly reactive metal comes in contact with that, then what will happen? It replaces that less reactive metal in that solution and it forms its own salt solution. Yes or no? Understood? Got the clarity? Look at the reaction. Iron plus copper sulfate. Here the merit student is iron, which is highly reactive. Comparatively, iron is highly reactive than copper. Yes or no? Now what will happen, students? If iron comes in contact with copper sulfates, do you think the components remain the same? No, it will show its reactivity. Yes or no? So iron replaces copper. And it occupies the space of copper. Of course, based on the valence, it combines in a proper ratio and it forms iron sulfate. And look at here, copper is removed or not? These type of reactions are called as displacement reactions, or these reactions, students, they are also called as replacement. Get displaced or not? Substitution. So here, why iron is replacing copper? Why? Because iron is more reactive than copper. That's it. Now answer this question. Can opposite reaction possible? For the same reaction, can the opposite reaction possible? That means I am asking Cu plus FeSO4 gives rise to what will happen? Nothing will happen. Yes or no? Why? Because highly reactive metal displaces less reactive metal, not less reactive. Can less reactive metal displaces highly reactive metal? Can a weak student replace topper? No. Yes or no? Weak student in the sense like the one who not interested in studies, who don't study simply. Okay, don't take otherwise this example. So students, here the point to be remembered is highly reactive metal displaces less reactive metal. These type of reactions are called as displacement reactions. Here one doubt, sir, how do we know which is highly reactive, which is less reactive? We have a series of metals which are already classified based on their high reactivity, moderately reactivity, least reactivity, that I will show you, students, in the coming slides. Next, here only we have. So the reactivity is given. The reactivity of metals can be known from the reactivity of series of metals. So from highly, in the decreasing order is given. Decreasing order means from highly reactive to the least reactive. Look at the elements, series of metals, which is highly reactive, potassium, then followed by sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, platinum. These are, how many metals are there? Here some students have doubts. Sir, almost 80% of the elements in the periodic table are metals. Almost like 90 elements, more than 90 elements are metals. Then why only few elements are given here? Why only few metals are given here? Why? Because, students, the metals which are most frequent in the chemical reactions, do we know scandium? Do we know titanium? Do we know other metals? In the reaction generally no, but everybody knows sodium. Yes or no? Sodium chloride. Got the clarity, students? But everyone knows magnesium, calcium carbonate. Everybody knows gold, silver. Got the clarity? Everybody know iron. So most frequent, most discussed, most compounds are generated from these elements only, students. That's why these set of metals are placed in the metal reactivity series. Now in this series, which is highly reactive? Potassium, followed by sodium, and so on. And here these are highly reactive, students. In this metal activity series, these are treated as highly reactive and these are moderately reactive, and from here these are least reactive metals. Here one point here, hydrogen is placed in the metal activity series as an odd element is given here. Hydrogen is a non-metal. Why it is placed in the metal activity series? Why? Because hydrogen can also lose electrons. What is the nature of metallic property? All metals lose electrons, whether 1 electron, 2 electrons or 3 electrons based on their valency. And what about the hydrogen? Hydrogen can also lose electrons like metal. That's why it is placed in the metal activity series. And most of the acids contains hydrogen, which is the property they release the H plus ions, yes or no? So that's why even hydrogen is placed in this metal activity series. That is the odd element. That's a non-metal but added in the metal activity series. So I hope you got the clarity. You have to remember this metal activity series. Why? Why? Because you should able to know about a highly reactive metal. Yes, sir. Then only you can able to write the reaction, right, students? Or simply given, can you displace by your own? No. You have to know whether this is highly reactive or not than the metal present in the salt solution. These type of reactions are called as, students, displacement reactions. So next, double displacement reactions. You already know what is displacement, right? A highly reactive metal displaces less reactive metal. That is displacement. What is double displacement? If the displacement happens from both sides, then that is double displacement. The chemical reactions in which two compounds interchange their ions and form two new compounds is called as double displacement reactions. Look at the reaction here. Silver nitrate AgNO3 plus sodium chloride NaCl. So here what is happening is, students, silver and sodium are displacing, exchanging their ions, exchanging their places. Yes or no? Getting displaced, simply changing their places. Got? That is double displacement reactions. Now you can easily answer the question, what are the components which are produced in this reaction? If sodium is taking place the place of silver, we will get sodium nitrate NaNO3, you can check, and we will get AgCl. Got the clarity, students? So here AgCl is a precipitate. We already discussed about precipitate in the previous video. In this video also we will discuss that. Next, PbNO3, lead nitrate plus potassium iodide. So which are getting displaced? This metal lead and this metal potassium. These are getting displaced. Double exchange of ions, student. That is double displacement. So what we get? Lead iodide and potassium nitrate. Look at the components which are produced in the reaction. So these type of reactions where the exchange takes place not only from one end, from both ends. That is double displacement reaction. Got the clarity? These are the main 4 types of reactions, students. Combination, decomposition, displacement as well as double displacement reactions. Precipitation reactions also double displacement only. These two are also comes under precipitation reactions. Why? Because they are insoluble solids. What is a precipitate? We discussed in the previous video. Precipitate means an insoluble solid is produced as a product. That is called as precipitate, and the reactions are called as precipitation reactions. So precipitation reactions are double displacement reactions only, students. They comes under double displacement only, in which one of the compound produced is insoluble. This insoluble compound is called as a precipitate and it settles at the bottom. Sometimes it has a characteristic color also. Based on the color also we can identify the respective precipitate. So right, next, redox reactions. Redox reactions are equally important, students. These are also the classifications of reactions based on oxidation reduction. Redox means oxidation and reduction. First of all, let us see what are oxidation reactions. Once again, what is the name? Oxidation. Oxidation, that means simply addition of oxygen. Yes or no? In oxidation, what is there? Which element is there? Oxygen. So addition of oxygen, the reactions which takes place by adding oxygen are called as oxidation reaction. Simple. Got the clarity? What are oxidation? Addition of oxygen. These reactions are called as oxidation reactions. But we can also define these reactions in terms of hydrogen also, but opposite. In terms of oxygen, addition of oxygen, right? But in terms of hydrogen, removal of hydrogen are called as oxidation reaction. So look at the reaction here. 2H2 plus O2. Here oxygen is getting added to hydrogen or not? Oxidation. Here hydrogen is gets oxidized. And look at the next reaction, removal of hydrogen. H2S, silver hydrogen sulfide and iodine gas H2. So in this reaction, hydrogen is removed from the sulfur. Yes, sir, students, in this compound. And look at the sulfur. Now what happens here? Hydrogen sulfide is getting oxidized. So oxidation means not only addition of oxygen but also removal of hydrogen also. Here one main point is oxidizing agents, students. What are these? Oxidizing agents. Very important. Many students will confuse between oxidation and oxidizing agents. Compounds which can add oxygen or a non-metallic compound or remove hydrogen or a non-metallic or a metallic element known as oxidizing agent. Simply oxidizing agents means, students, they make other elements or compounds to undergo oxidation. What are oxidizing agents? They help opposite elements or compounds to undergo oxidation. Sir, how do they help? They give oxygen. Yes or no? Or they take hydrogen from them. Got the clarity? What that is oxidation? Yes or no? What do? They help opposite element or compound to undergo oxidation. How do they help? Helping means what? In terms of reactions, they give oxygen. Okay, you undergo oxidation. Or if hydrogen is there, they remove hydrogen. That is also oxidation, right? Now, this is the main point. Listen. This is oxidizing agent. If it is providing oxygen, then itself it is undergoing oxidation or reduction? Answer. It is making other element to undergo oxidation. Simply it is giving oxygen. It is releasing, it is removing. It's oxygen or not? That means itself it is undergoing reduction. Itself it is undergoing, students, reduction. So, for example, insurance agent is there. He will provide insurance to the other people, yes or no? Or every time he will take insurance only? No. Simply oxidizing agent also, it makes opposite element or compounds to undergo oxidation. In this process itself it undergoes reduction. Oxidizing agents undergo reduction. So what is reduction? That is the next slide. Reduction is simply opposite to oxidation is reduction. What is oxidation? Addition of oxygen, removal of oxygen is reduction. In other way, what is oxidation? Removal of hydrogen is oxidation. Addition of hydrogen is reduction. Understood? Both opposite. Addition of oxygen, removal of hydrogen is oxidation. Now answer, what is reduction? Removal of oxygen, addition of hydrogen is reduction. So we have the reactions here. H2S plus I2. Addition of hydrogen is getting, what is undergoing, which is undergoing reduction, students, here? H2S plus I2 gives rise to Ha plus S. Here sulfur is undergoing oxidation, but iodine is undergoing reduction. Why? Because hydrogen is added to iodine. Yes or no? And removal of hydrogen, look at here. ZnO plus C gives rise to Zn plus CO. Here zinc oxide is reduced or not? ZnO, oxygen is removed. So it is undergoing reduction. You can see ZnO becomes Zn, that's it. Zinc oxide becomes zinc. What happened before the reaction, after the reaction? Oxygen is removed, right? Next, what is reducing agent? Simply opposite to oxidizing agent. Oxidizing agent makes other compound to undergo oxidation. Reducing agent makes other compounds to undergo reduction. Understood? How it can take oxygen from the other element? Yes or no? Or it can give simply it can take oxygen from the other element, right? Or what will happen? It can give hydrogen to the other element, right? What is reduction? Simply removal of oxygen or addition of hydrogen. Now answer, oxidizing agents themselves, they undergo reduction. What about reducing agents themselves? What do they undergo? Same, oxidation, right? Why? Because they are taking oxygen. They are helping other compounds to undergo reduction. Yes sir, they are giving hydrogen. They are helping other compounds to undergo oxidation. Themselves they undergo reduction, oxidizing agent. In the case of reducing agents, they make other compounds to undergo reduction. Themselves they undergo oxidation. So here some confusion point is there between oxidizing agent, what is simple, but you have to make a point about that, student. Simply oxidation, reduction. So if both process takes place simultaneously in a given reaction, and that reaction is said to be a redox reaction. So the reactions in which both reduction and oxidation takes place simultaneously is called as redox reaction. Look at this reaction here. ZnO plus C gives rise to Zn plus CO. Here ZnO becomes Zn. Is this process oxidation or reduction? Answer. This process is reduction. Sir, why? Why? Because oxygen is removed. Carbon, students, once again. Carbon became into carbon monoxide. Now answer, is this process oxidation or reduction? Oxidation. Yes, sir, no, why oxygen is getting added? So in a reaction, if both oxidation and reduction takes place simultaneously, Half reaction is oxidation, half reaction is reduction. And this complete reaction is said to be redox reactions. In general, reactions are redox reactions only. Got the clarity about oxidation and reduction, students? Main point. And you have to make sure about the difference between oxidizing agent, oxidation, reducing agent, reduction. Oxidizing agent means itself it doesn't undergo oxidation, right? So itself it undergo reduction. So these clarities you have to concentrate. So effects of oxidation reactions in our daily life. So where we can expect these oxidation reactions in our daily life? Everywhere. Combustion reactions, something is spoiling, rancidity, all comes under this oxidation only. Corrosion, it is a degradation of metals due to their reaction with oxygen. For example, a metal is there, or iron is there. Iron is a silver color. Over exposure to the moisture, the silver becomes brownish color. Yes sir, on the coating, on the surface. Why? Why? Because iron undergoing oxidation, it is converted into iron oxide. That process is called as rusting, and the compound is called as rust iron oxide. So look at, it's a common type of corrosion. It is formed when iron comes in contact with moisture. As a result of corrosion, a reddish brown layer of ferric oxide is formed, which is called as a rust. Look at iron in presence of oxygen and H2O, it forms, what is the compound, students? Fe2O3 dot NH2O. That means N means any number of H2, water of crystallization, and this is called as rust, and this process is called as oxidation reaction. Rusting, corrosion, all comes under oxidation only. Yes or no? Statue of Liberty, what is the color? Pale bluish green in color. Yes or no? Do you know its original color? It is copper. It is made up of pure copper. What is copper color? Many of you have copper bottles also, right? Like shiny brownish kind of color, right? But why it is in that color? Why? Because it is corroded. Itself it is corroded. That means in the presence of atmospheric gases like oxygen, carbon dioxide, H2O, it converts into copper carbonate and copper hydroxide. That's why this process is called as corrosion, takes place in the presence of oxygen mainly and H2O and sometimes carbon dioxide also. So all these process comes under corrosion, students. Next, effects of corrosion. What are the effects? Statue of Liberty means it is not weakening, but here the effects mainly in terms of rusting of iron. It weakens the metal and makes it brittle and reduces the tensile strength. Yes, correct. A railway bridge is made up of pure iron. Over the long period, what will happen? It undergoes rust and slowly the holes will appear, yes or no, and it collapses. Got the yes or no, students? That is, rusting mainly affects the quality of the metal. Then what we can do? We can simply paint, or we can apply oil, grease, not for bridge, for machinery kind of thing. For bridges kind of thing, we have to coat with other metal like galvanization, electroplating, so alloying. So there are different methods are there. We can prevent corrosion, rusting mainly. Sir, why not Statue of Liberty? That Statue of Liberty, the upper compound is not a brittle compound. It's not a powdery compound like rust. So it is good only. Simply it formed and it is being there as it is. Nothing is happening, right? That is okay. Next, rancidity. Simply, rancidity means, students, take any food item, keep it on their table for long time. For example, banana. 3 days, 4 days, 1 week, 1 month. What will happen? Slowly black spots will appear, yes or no? And what is happening? Ultimately, it will undergo decomposition, fungus, everything will grow. The reason is that process is oxidation process. Why? Because this all bacterial fungal growth takes place in the presence of oxygen only. Remember that spoiling of food is called as rancidity. So often the food cooked is changed in taste if it is kept in open for long. This is because the fats gets oxidized and hence degraded with the time and start emitting bad smell. Yes, sir, they create bad smell. And the oxidation of oils and fats present in the foodstuff resulting into a bad odor and taste is called as rancidity. That means over the long decomposition process, what will happen? Will get a bad smell or not? For example, students, anything, potato chips are there. They are also undergoes oxidation, spoiled. Any food item will undergo oxidation and slowly what will happen? It will get decomposed. If it get decomposed, it gives a very bad smell and taste also not good for health. That's why we used to keep all the food stuff in the freezer, so into the fridge. In the fridge, do you think the decomposition doesn't happen? Decomposition happens, but it happens slowly. Why? Because the temperatures are very cold, na? And under the cold temperature, the rate of decomposition is slow. That's why. For example, lemons, keep the lemons in the fridge for 1 month, are they still fresh? No. Decomposition takes place but very slowly. And what is the main reason for the decomposition? For the bacterial growth, fungal growth, oxygen is the main reason. So we have to, sometimes decomposition is good for the nature only, for the nature. But sometimes we need to prevent this decomposition for the long storage of foods, yes or no? So methods to prevent rancidity. Food should be kept in airtight containers to prevent its oxidation. Nitrogen gas can be flushed while packing foodstuffs like chips, etc. Antioxidants can be added to the foodstuffs. All the food storing, potato chips are there, packets. It contains full of air. Do you think, what does it contain? Normal air? No. It contains nitrogen. Normal air contains oxygen and water vapor. They are the main reason for this rancid oxidation process. So that's why what do they do is, they'll flush out all the air and then add nitrogen. So in the presence of nitrogen, this decomposition will be lowered, will be stopped. That doesn't mean not completely. It has a lifetime that slowly it will undergo decomposition. So with the why? Because this foodstuff also contains some water molecules, also contains some oxygen. Yes or no? There is no direct supply. That's it. So to some level we can stop that. Got the clarity? So that's how we can prevent rancidity, but not 100%. We can increase its lifetime. That's it. So this is all about, in this chapter, chemical reactions and equations. I already have said this chapter is very important to understand what is a reaction, how to write a reaction, and how to represent it, what does it indicate, and what are the types. So I hope you got the clarity, students, and that's all for today. Thank you.